Okay, so this video is for lesson 22-4, and it is solving uh, right triangles. Okay, so in last class we went from problems like this when they gave you the angle, right? So let's say this one was 25 degrees, and this one was 17, and this one was x, right? And then you were like, well, this one is the hypotenuse, this one is the adjacent. So adjacent or hypotenuse, I have to use cosine of my angle 25 degrees, which is equal to x over 17, right? So then you have to use your calculator. But the difference in today's lesson is that this angle is not given. So what we're going to do today is find that angle, okay? And for that, you will need your calculator again, okay? And you are going to use the inverse functions. Now in this calculator, inverse functions are like right on top of sine, if you can see it. So here's your sine, and here's sine inverse, so it has as the sine with a -1 as an exponent, and we say sine inverse. So let's get right to it. So if, okay, so we can say it's definition. So if sine of A, okay, meaning of any angle, is equal to x, then sine inverse of x is going to give you the measure of angle A. Okay? Similarly, if you have the cosine of A equals x, then cosine inverse of x is going to give you the measure of angle A. Okay? And then finally, if you have the tangent of angle A equals x, then tangent inverse of x is equal to measure of angle A. Okay? Now, remember that we say inverse. Okay? So you can say inverse tan, inverse cosine, or tangent inverse. Okay? So that's the way it's written. So let's go ahead and do a few examples with the calculator. So here, using calculator. And so let's just check that we're on the same page. So remember, we're going to do sine of 30. Okay, we should get 1/2. So sine of 30, and that it's indeed 0.5. Okay, so that is 0.5 or 1/2. So now, let's say, what if I want to do sine inverse of 0.5? Okay, now I'm going backwards, so I'm getting this value here, and I'm trying to get my angle based on this definition on top. So all you have to do is, okay, so instead of doing sine, you're gonna get sine inverse. So you do, in this calculator, you have to press second and then sine, and you see then we got sine inverse, and then you do 0.5, and there it is, 30 degrees. Okay, so as you can see, sine of 30 is 1/2, but sine inverse of 1/2 is 30. So the inverse is giving you back that angle. It's like going backwards. Okay, so let's do a few more. So let's do cosine of negative 0.5. I think that should be 60. So let's see, cosine inverse of 0.5. That is indeed 60 degrees. Okay, now let's do tangent. Second tangent of 45 degrees. No, I'm sorry, of 1. Let's clear this one, and that should give you 45 degrees. Okay, now let's try one more. Let's just pick something random. Let's do sine inverse of 0.2346. Let's see what we get. So second sine of 0.2346. That gives us 13.56 degrees, or 13.56 6 degrees. We will round up. Let's do one more time, and let's do second cosine of 7.5. Okay, what? So when you do this, cosine of 7.5, you get an error. What does that mean? Well, in order to be able to get the cosine inverse, okay, these values have to be less than 1, okay? And it has to do with the way we graph it. So I will show you, we have time, how to graph cosine and sine, and it has to do with the domain of cosine inverse and sine inverse. Because just watch, what if we do cosine inverse, and the same thing is for sine, okay? So cosine inverse of 0.99999, right? It's really close to 1, but you get 0.810. Now let's do cosine of 1, that should work, but anything bigger than 1, okay, it gives you domain error. That's why. And the reason is because that one is greater than 1. Okay? All right, let's go ahead and do some actual examples where you have to apply this. So here we go. I have example number 1. So we have sine of A is equal to root 3 over 2. Okay, in triangle ABC, where C is right. Okay, where C is the right angle. Now, I know I can find my angle, but in this problem, we need to find all angles and sides. Okay, so first thing we have to draw a triangle. Okay, now we know this one is C. Now, and that's a right angle. Now sine, so I'm going to write SOHCAHTOA. Sine is equal to the opposite over the hypotenuse. So I know the hypotenuse is always that one. So if I know this is the opposite, and that's the hypotenuse, I know that one's 2. And then the opposite is going to be root 3. Okay? And this one is A, that one is B. So sine is opposite over hypotenuse, exactly what we have there. So now, if I want to find my angle, angle A, all I have to do is sine of A is equal to root 3 over 2. You may want to change that into decimals if you feel more comfortable doing that. So let's go ahead and do that. So second root 3 over 2, and that gives you 0.866. So we can do measure of angle A is equal to sine inverse of 0.866. Okay, so what I did, I took that and changed it into decimals, and now I'm going to plug it into my inverse function. So I know a measure of angle A is going to be whatever I get from here, and that is 59.997. So we can round it up to 60 degrees. Okay, so that means this one is 60 degrees. Therefore, this one up here has to be 30. Okay, so now we can find the other side using multiple ways. So one way could be 30, 60, 90, right? So another way could be Pythagorean theorem, or we can even use cosine to solve for it, or even tangent. So for me, I like using the Pythagorean theorem because I already know two sides. So I'm going to do with a squared plus b squared equals c squared. I'm going to say my a is root 3. I'm going to square that. Plus b squared is equal to 2 squared. Now root 3 squared is just 3 plus b squared, and 2 squared is 4. We subtract 3 on each side, and you get b squared is equal to 1. Then we take the square root, so that means b is equal to 1. Okay? So that is how we use inverse to find the missing angle, and to find, and having that we can find everything else. Now, keep in mind that this is a 30, 60, 90, and it can make sense. So you just divide this by root 3 over 2, root 3 by root 3, and you get that. Or you can divide this by half, and that's what you get that one. All right, let's look at another example when it's not as nice as this one. So let's see, example number 2. Let's say I have this. I'm gonna give it to you already set up. This one we're gonna call the x degrees because that's what we're finding. That one's 41, and that one is 9. So let's label the triangle. So I know this one is the hypotenuse, this one is the adjacent, and this one is obviously the opposite, but we're not asked to find that one. So if we have the adjacent and the hypotenuse, so now adjacent and hypotenuse, so that means I'm using cosine. So I do cosine of x, right, degrees, because that's what we don't know, is equal to adjacent, which is 9 over 41. Okay, so then, like I said, you may want to change that into decimal, so you can just put it in like that in your calculator. I'm going to keep it like that, so I know now I'm going to use my inverse functions. So I know that angle is going to be cosine inverse of 9 divided by 41. So that means I have to use my calculator now. So second cosine inverse of 9 divided by 41. Okay, and we get 77.3 degrees. So yeah, so 77.3 degrees straight. You always try to round to the nearest tenth. So there is your answer. Okay, so that's that angle. Okay, let's look at one last one. Let's say I have this right triangle here. That's my right angle. This one again is my x degrees. That's 13. That one is 17. So let's go ahead and label this. So across from x, that's my opposite. Next to it, that's my adjacent. And across from my right angle is the hypotenuse. I'm going to label even though we don't need it. So again, SOHCAHTOA here. So what are you going to use? Well, you have the opposite, but you don't have the hypotenuse, so you can use sine. You have the adjacent, but you don't have the hypotenuse to use cosine. But we have the opposite and the adjacent, so we're going to use tangent. So tangent of x degrees is equal to opposite over adjacent. Okay? So let's go ahead and solve for it. So this is tangent, so it means I'm going to use tangent inverse of 17 divided by 13. So that is going to give you .5264. So that's 559. Okay. Now it depends how what the problem is asking you. They may ask you round to the nearest angle, so that's round up to 53 degrees. Okay. Like again, it depends on the problem. So if you have questions, please come and ask me. Okay. All right.